Hello. Hello and welcome to United Astronomy Clubs of New Jersey. While a couple people are probably going to be filing down here because we are on site in Jenny Jump State Forest in Hope, New Jersey. So while people file down, I'm just going to go over the usual things. Do check us out on our website, uacnj.org. That's where you're going to find a list of all our talks and information about our organization and our aim to bring science and astronomy to a lot of people, as many people as we can. Uh, in addition, you'll find information about our the clubs that are actually members of us because we are a club made up of many other clubs. So do check them out as well, so that you can see and find your local astronomy club. With that, you can also check us out on our socials. We have Facebook, Instagram, Twitter. We do have a Discord channel that feel free to hop in there and ask any questions you might have. In addition, we are a nonprofit, so we want to thank all of you for coming out, hitting those like and subscribe buttons when you join us online for these streams, because we do live stream these on YouTube and Twitch. So do remember to do that because even the free support is very nice to help us keep going. Right, so for all the people who are here, first is the safety briefing. If you need to use the bathroom, it is the porta potty to my left, your right, all the way in the back of this little canopy. And then that. No. Is it because I'm too close? How about now? Yay! It's always slightly alarming when you hear speakers go off and you're like, oh god, what's exploding behind me now? So, in case of things like that, don't worry about it. As long as we're not running and screaming, you shouldn't be worried and running and screaming either. Uh, like I was saying, if you guys need to use the bathroom, and I fully, if you need to check yourself, because I nearly got very scared there. Feel free to, like I said, use the porta potty in the back. We also do have a museum and gift shop area that you can check out during or after the stream. I will be behind the little sales desk after the stream because fortunately I still cannot be in two places at once. We do have a number of scopes open. I don't know if we're going to be able to see too much because it is very cloudy. That being said, feel free to approach any of our volunteers. Most of them are wearing name tags like you see on me because someone managed to actually put my name tag on me this time. And, ask if they have anything visible through their scopes. With that being said, when we go to leave, headlights on. We like not getting run over, and I'm sure you feel the same way that you also do not want to get run over. And if we have any flashlights, because we are approaching, yes, new moon is tomorrow, so it will get a little dark as the night progresses. So if we are using flashlights, keep the light pointed towards the ground so we don't accidentally blind people. With that, we're going to get into tonight's talk, which is all about astrophotography, with Mike Dzwinczyk. Mike is a chemist who worked with lab instrumentation in the pharmaceutical industry. Photography has been a lifelong interest, and with the growth of digital photography, he was able to actually combine his interest in astronomy with photography. He has been doing astrophotography for the last 4 years and must thank the UACNJ astrophotographers for their willingness to help. This, along with the internet resources, allowed him to take up and enjoy this challenging hobby. And with that, Mike.
Hello? Okay, much better. Okay, my talk today is on basic deep space astrophotography, which is a mouthful. and it's really a very technical topic. And we have people here who have built their own observatories, and we have people who have never taken a photo. So I'm going to go through a lot of information, and at the end there's going to be questions. Definitions, some calculations you may need to do, the type of gear you need to do deep space astrophotography, objects to photograph, and of course example photos. The one on the right is the North American and Pelican Nebula, and that was actually taken a couple of years ago. I took it with a regular SLR camera and a zoom lens. So if you have a decent mount so you can track the stars, you can get a nice photo, and you can tell a photo is decent by the color of the stars and if they're round. So that's one of the things to look at my photos and other people's photos. If the stars are not round, they didn't have good tracking, and maybe their polar alignment wasn't good. And if the stars are too big, they're bloated, that means they over-processed it. And I'll show you examples where I screwed up doing things like that. First, what is deep space? Well, deep space is actually everything beyond the solar system. So we don't count the planets, the moon. It's going out into the Milky Way. And when you get out into the Milky Way, you see stars, you see star clusters, you see nebula and other galaxies beyond the Milky Way. And just while I have a moment here, nebula are just giant gas clouds that are usually illuminated by a bright nearby star. So sometimes they have different shapes, like the North American Nebula I showed you. What's pictured here is a photo I took a couple of years ago of M101, which is another galaxy. It's the Pinwheel Galaxy. And the objects in deep space are objects that are a long ways away from us, many light years, thousands of light years, millions of light years. This galaxy here is 20 million plus light years away. That means you're looking at a photo I took that's 20 million years old now. We don't know what happened to this galaxy, but that's how long the light took to reach us. And of course, light travels at 186,000 miles a second. So that's a long way. If we have time at the end, there's a supernova that an amateur scientist found last month in this galaxy. And I took a picture of it from here. And a supernova is a giant explosion, the brightest explosion in the universe. And it's oftentimes brighter than the core of the galaxy. Well, I'm not going to get into the chemistry of all this electromagnetic energy, but I do want to mention, you may hear me say the word photon, which is a particle of light. That's the best way to think of it. And when we're collecting photons, the more we can collect, the better our photos are. We're talking about astrophotography, deep space. We're talking about very dim, sometimes broad objects, but very dim. So we want to optimize it. When I got into astrophotography, I learned a lot about astronomy. And one of the things I learned was the color of the stars means a lot. And as an example, there's 3 stars, Rigel, our sun, and Betelgeuse. They're different colors. And the bluest stars are actually the hottest. And the reason they're the hottest is because hydrogen is plentiful and they're burning it fast. The sun is in the middle, and Betelgeuse, which is on the shoulder of Orion, the hunter, is an older star, burned through a lot of its hydrogen, so now it's cooler and it becomes red. So now I already said some of this. What do we consider for good astrophotographs? The number of photons of light you collect by your camera sensor, that's the bottom line, because you're talking about dim objects. You're trying to collect as much as you can. And that's why almost all the pictures I'm going to show you were exposed for 2, 3, 4, 5 hours. And each of those sub-exposures could have been a minute and a half, 2 minutes, 5 minutes, 7 minutes. And then we stack them. There's techniques you have to use to get the picture out. And I'm not going to go into a lot of that detail, but the other thing we want to do is make sure we have different focal length telescopes and cameras, because some objects are very small when you look at them, others are much bigger. Andromeda Galaxy, we'll be talking about that. It's a huge galaxy. It's the closest galaxy to us. It is actually 6 times larger than a full moon. That's how big it is. So you could never use a big telescope to look at it because you'd only see a part of it. But it's very dim. That's why we don't see it in the sky. The other important thing is to reduce the camera noise, the graininess. And you do that by techniques like you have to avoid any motion. So you use very accurate, precise tracking mounts. You use post-processing where you stack many photos. The elevation of the target you select. If a target is low on the horizon, you have to shoot through a lot of atmosphere, which means you're going to get interference. If it's higher up, then you're shooting through less atmosphere. It makes a difference. The other thing I always shoot, I make sure there's no moon available. So tonight would be a good night, because that does make a difference. I found out the hard way. And of course, even minor things like the temperature of your sensor, your camera. You know, you're exposing a camera. When you take a normal photo, it's a split second. Here you're exposing it for 3, 4 hours. Well, the sensor heats up and causes noise. That's why the better Astro cameras actually have a cooling system that you program. We're sitting in a light polluted area of northern New Jersey. This happens to be about a Bortle 4. A Bortle scale tells you how much light pollution exists. Well, I live in Parsippany. That's about a 7. If I have time, I'll show you a couple pictures I took from there. And they're not as good as from here. And if you go to some of the national parks with the dark sites like Acadia, it's a 2 and a 3 Bortle scale. The lower the Bortle scale, the less light pollution, the clearer your pictures are. And I'm going to show you an example. Here's 2 photos. I can't swear that this is the only difference, but the one on the left is in a more light polluted area, so you have to limit your exposure. The one on the right, which was a lot of work to make it look that way, is in a much darker site, so you get a lot more nebulosity. You see the gas around the objects. And we'll talk about that later. So what's our biggest problem in astrophotography? The Earth is rotating. That's our problem. The stars are standing still. The Earth's rotating. So if you were to take a photo, I got this from the internet, and pointed a stable tripod with an SLR camera and opened it up for an hour, this is what you'd get. And I know they're pointing directly to the North Star, the polar star, because it's the only star that doesn't come in a counterclockwise circle. We're lucky to have a star like that we can focus on. But there's a formula for this too. Being a chemist, I love formulas. What if you have a stable tripod and you want to take a picture with one of your lenses, but you don't want the star trails? Well, there's something called the 500 rule. And what that means is, if you know the focal length of your camera and you know your exposure, what you do is you take 500, you divide it by the focal length of the camera, and that tells you how many seconds you can expose your sensor without getting star trails. As an example, if you take a 50 millimeter walk around lens, 500 divided by 5, that's 10 seconds. If you go over 10 seconds, you'll start to see star trails. So that's a nice rule for people just beginning. And here's an example I took, I think this was in Vermont, on a fixed tripod. Constellations. Some people love the star trails, and you can be very creative with them. The moon you can take, because these are all very short exposures. Comets, meteors, shooting stars, in other words. Here's a photo I'm proud of. I took it in Maine. It's the Milky Way. It's an Abortal 2 class, so it's very little light pollution. There were so many stars, I don't think I could have picked out Polaris. But I did cheat a little bit. You see how nice the land looks? I took that earlier in the day with more light, and I combined the two. Otherwise, it'd be black. And it was about a 15-second exposure, but I used that rule, so it was a wide-angle lens. Here's a couple more photos I just took with my SLR and a stationary. Now, these are heavily cropped, and the moon is a good target because it's bright, and you don't need to worry about the motion too much. Now, what do you need to get into deep space astrophotography? Well, the first thing is you need some sort of a tracking mount to eliminate the star's motion so you can take longer exposures and get all the details that you'll see in some of these photos. You also need some sort of lens or telescope, a camera. Cooled is preferred as you get further into the hobby. Some sort of power, either a battery or a plug to control the mount. And then you get into the good, challenging stuff when you start adding a computer and you can do something called guiding. Because there's limits to what you can do with a tracking mount, and I'll show you those limits. But if you could put a second telescope on, this is called guiding. You're going to guide your mount. And the second telescope, with software and all that, only tracks one star. And as soon as that star deviates the slightest amount, it sends a signal to your mount to tell it, get back to where you should be, correct it. And that constant correction is what allows you to take 5-minute exposures and still get pinpoint stars. It's not easy, but if you like the challenge, astrophotography is for you. You also need money, by the way, to do all this. Here's my first tracking mount, and people do sell very simple tracking mounts. You can put your camera on. This is the Ioptron Skyguider Pro on a regular tripod, and what happens is you still have to do some basics, but you can do this without a computer. This little tracking mount only does right ascension tracking, not the declination, so you make sure you have about the right latitude. And then what you do is you do a polar alignment. You need to do a good polar alignment. There's a polar scope built into a lot of these really beginner setups. Once you have the polar alignment done, you have to find your object, and that could be tricky because there's no go-to, so you have to know the sky a little bit. And once you are on it, it's going to slowly track, and it'll allow you to take a minute and a half exposures. And I did take some pictures myself, and my first one with a tracking mount was on the left. I'm probably most proud of that picture, the first one on the left. It doesn't look like much, but that's actually Andromeda. And when I took that, I would manage to get a minute exposure with round stars, which was an accomplishment, which means I did a lot of things right. I also saw it was oval, and it had some dust lanes in it, so I knew it wasn't a star. And of course, I didn't realize that in Vermont, the dew really gets heavy. And after I thought I took a dozen pictures, I went out, and it was like 5 that were not covered with dew. And that was the result. The second one I got better at, and that's a minute and a half with a 300 millimeter lens. So, and you do get better with practice. Now, we have a celebrity here, Mike, let me get his last name correct, Spoletti. He just started, and he took this photo right here in March with a similar sky guider. And what this is a photo of is two galaxies together. He's using a 135 millimeter lens, f I believe it's an f 2.8 lens. So it's a nice lens, but he's just got a simple tracker. But he got a real good alignment. You can see how nice the stars are. He was able to process it probably better than I could with a nice processing software. And he took 110 90-second exposures. And this is one of his first photos. So I applaud him for such a great job. And that's on the left is Bode's galaxies, and on the right it's called the Cigar Galaxy. And I was looking at this picture after I spoke with Mike, and I noticed some nebulosity in the background. And I'm thinking, boy, that's unusual. So I researched it a little bit, and this is what I found on the internet. Somebody had taken this photo, and what Mike actually captured was integrated flux nebula, which I had never heard of. And what that nebula actually is, remember I said a nebula is a gas cloud illuminated by a star usually, or an emission. This is actually out beyond the Milky Way, gas clouds, and they're illuminated by the Milky Way galaxy itself. And he actually caught a little bit of that in his first photo. So very good, Mike. But here's a photo I took, I think it was earlier this year. When did I take that? March of 23, the same time. And that's Bode's on the left, the cigar on the right, and I blew up the cigar for you so you can see the details. And this is a bigger telescope. Instead of 135 millimeter, this is 800 millimeter. And the exposure is the cameras are different. But you can see that the same information you can take with different setups and get different effects. But you want to see one of my better photos? We talked about Andromeda, and there it is. I took that right here. It's about a 3-hour exposure, and it's with the same gear that I took the other two. But remember I told you Andromeda is big, so I couldn't use an 800 millimeter telescope. I actually used a much smaller 644 millimeter telescope with the Astro camera. And you know what? When you look at this, you see the details in the dust lanes. You see a lot of details. And you see those two fuzzy objects? Those aren't stars. Those are called satellite galaxies. Each one of those also has millions of stars. And remember, Andromeda is the closest galaxy to us. It's much bigger than we are and heading right for us. But it's 2.5 million light years away, so we got time. 2.5 million light years away. So the key elements, how do you do this? How do you take these pictures? And I know I'm going beyond the basics, but the first thing is you have to have a well-balanced mount. There's a counterweight. You can't put a lot of stress on the mount because it's trying to do a tremendous job, arc seconds differences, tracking those stars. You have to have a very accurate polar alignment. That's why people tend to go from manual polar alignment to electronic polar alignment, which there are many ways to do. Focusing, I learned the hard way over the years. You can't rely on the camera to focus. If you start, you have to get pinpoint stars, so you need perfect focus. Good guiding accuracy. I told you that second telescope has to tell it exactly where to go, the mount. Good seeing conditions. Don't shoot with the moon. Shoot high up and collect all your darks, your flats, your dark biases, because they're used in enhancing the photos and bringing out the details. And I'm not going to go into the details of what these are, but you basically put a cap on your telescope and you shoot dark frames. Those are important. And then there's a slew of software you use depending on what level you're at and whether you're using a computer or not. The Badenoff mask I have to explain because it's critical. Everyone uses it, or they use electronic autofocusers, which I don't do. And on the left, you see when you put this mask over the front of your telescope or lens, and you take a 5-second exposure of a star, of a bright star, what you want to see is this on the left. That's in focus. If it wasn't, one of those lines would be moving up and down, and you'd have to keep focusing until you got it into this configuration. That's an interference pattern, and that's the Badenoff mask. It's really phenomenal, and everyone should use it that gets into astrophotography. My first guided rig, I'm not going to go into it, but I did manage to use an SLR camera with a computer, and you see on top there's a little telescope with a little secondary camera, and I was able to learn on that how to take some pictures, and then I moved up to more equipment. This is a hobby that gets expensive quickly if you enjoy it. And what happens is there's a lot of small objects that you want to photograph, and you say, gee, I need larger aperture, I need more light to come in, I need bigger focal lengths. So I'm not going to go into the details here, but this is a list, not exhaustive. There's people that have a lot more than me. I only have one rig that I could set up at a time. There are people that have 4 or 5 rigs they can set up, so they're getting 5 pictures while I'm getting 1. But I now have a telescope that goes from 400 millimeters focal length. I have another one that goes to 800 millimeter. I have another one that I just got that goes to 1600 millimeters. That's nice for a galaxy season. And of course, each one has its own positive and negatives. I use 2 refractors and 1 reflector. The collimation on the reflector can be tricky, so you don't want to start with a big telescope. You want to start with a smaller one. I do want to mention a couple of sites that I highly recommend. They've been very helpful to me, and I still use them, and I think most people that do astrophotography use them. Astronomy tools. How do you know that the camera you're going to use and the pixel size it's using is going to match the focal length of your lens? Or, that's beyond what I ever thought about. Part of it is depending on the conditions. Well, this gives you simple calculations. You can put in the info, and it'll say it's a good match. You're not going to oversample or undersample your pictures, which means you'll get better pictures. And I used it for my guide camera. When I bought a second guide camera, I was using that little 120 millimeter guide camera for an 800 millimeter telescope. It wasn't good. It wasn't sensitive enough to give my guiding well. So I went to a 280 millimeter, and I used this website. The other thing that I've started using more now, and this is whether you're doing astrophotography or just observing, there's a site called telescopius.com, and you can actually put in information about which telescope you have or which cameras, and it'll show you the framing, what you're going to see when you look through the telescope, and it'll tell you what objects you can look at, the magnitude, how big they are, how bright they are. So it's very useful. That's just a picture of the back when some of the astrophotographers get together, and there's a lot of gear everywhere. To start taking pictures, it takes an hour to set up. So you have to be dedicated, you have to like it, and you have to like the challenge of making it all work. I'm going to show you what one frame looks like when Mark showed me before one of his frames through a giant telescope, But through a regular 644 millimeter telescope, this is one frame for 4 minutes of Andromeda galaxy. And it's a nice, the reason it's so good is the camera is quite good. It's a cooled C-size sensor camera, Astro, but there's a lot of detail considering it's one exposure. And remember, the picture I showed you of Andromeda was 3 hours of these exposures stacked and worked up. So that's what it takes. The second step after you get these 3 hours is to stack them. And this is what you get the first time you stack them. And you go, my gosh, what happened to my photo? You know, it's kind of scary the first time, but that's good. It means you didn't overexpose your stars. They're not oversaturated. You expect to see that everything's embedded in it. And then when you bring in other software and you do what's called a stretch, it brings out more detail. But you're not done. You got to do things like background extraction, transformations. I use Searle. There's many different software packages. Some are free, some are you have to buy. And then you remove green noise. The color balance has to be right. You do background neutralizations. You do histogram equalizations. Sometimes the processing will take as long as shooting the photo. So I don't want to minimize that. That's really important. I'll show you some examples of dramatic differences between when I was learning how to process data and the intermediate level I got to now, maybe. And the hard part is you can get all different effects when you do this, and you don't know which one is the best. It's an art. It's not just science and facts. It's kind of artsy. You have to make it look good, depending on what you learn about astronomy. And there's an exposure I took when I was learning, and it looks pretty good. I loved that photo when I got it, and I showed it to my family and friends. They loved it. Now I don't like it so much. The reason is the stars are a little bit bloated. There's like a red tinge to it. I don't think the color balance is good. There's a lot of detail, but the background isn't flat. It isn't, there's a reddish tint, I think, to the background. And of course, that was in 2021. So when I redo that photo, this is what I ended up with. And you can see, I like this one now. Maybe in a year or two, I'm going to hate this one too. You know, that's what happens. The level keeps increasing. And you see how nice and neutral the background is, how much detail is in the dust lanes even more than before. And this was a better camera also, so the conditions weren't the same. But the processing takes a while. And you can see the 2 satellite galaxies. And this was my main AT-115 millimeter refractor telescope with a reducer which makes the field flat. And that's important when you work with telescopes in general. You want a flat field so the stars are round in the far corners and in the center. You're always looking at that. How small are they? How tight are they? And how round are they? And do they have a little bit of color? Some should be a little bluish, some a little reddish. Then you know you did a good job processing. I have to talk a little bit about my setup. I already told you it takes an hour. I'm not going to bore you with it. But basically, you drive up, you pull out the tripod, you bring your level out, you level it as accurate as you can. It's got to be really level. And you make sure it's pointed about north. You know, you have to know where Polaris is. And it's still light, so you kind of have to kind of know from your iPhone, whatever, where north is. Then you take the mount out, and that's usually heavier. You place it on, you lock it in place, you take your telescope, you put it in place, you put your counterweights, it's all heavy, 2 11-pound counterweights go on, and now you try and balance it so it's equal perfectly balanced. That's really important if you're taking long exposures so that the tracking and guiding is accurate. What do I do next? Oh, I wait for it to get dark because now I have to do a very accurate polar alignment. And you can't do it until it gets dark enough so you can look through the mount and do a manual polar alignment or electronically do it on a computer. And you have to move the right ascension and declination controls on your mount to get it perfect. Once it's perfect and you're satisfied, you're level, you're pointing north, and it's starting to get dark, you see more stars. Next step is focus. You got to get a good focus or your whole night will be shot, believe me. So what you do is I usually know ahead of time which bright star I'm going to go to. And I tell the computer, go to the mount, go to Alnatic or something, or Ceres. And it centers it. And now what I do, I put my Batinov mask on, remember? And I take a short exposure. And sure enough, it's not in focus. So I use the focus knob on the telescope a little at a time until I get that perfect alignment. Now I know it's focused. What do I do next? I got to go to my object I want to photograph, Andromeda Galaxy. I tell it, go to Andromeda. Shh. Goes to Andromeda, center it. Am I done? Can I start shooting? No. You forgot about guiding. I got to start my guiding procedure, which means the other telescope and camera that's mounted on my telescope, I have to start that. PhD program is PhD 2 is the name of the program. It needs to calibrate 5 minutes. It calibrates if everything works well, and it picks a star on its own that it's going to monitor. And these days we use multi-star guiding. It's more accurate, especially if you have flex in your optical train. So anyway, now it's guiding and it's showing you how well it's guiding. Hopefully you're under 1 arc second. That's good if you're under 1 arc seconds. That's all related to your camera size, your telescope, and all that. So I'm guiding, I'm on my target, and I've pre-programmed my computer that I want to take 3 hours of photos, each one being 4 minutes long. I hit it, and I usually wait for the first photo to come out to make sure everything is still looking good. My stars the tracking is good, but I go inside. I'm not an observer. Observers have to spend the night out in the cold observing. Photography has that advantage. You go inside and enjoy the evening. And of course, these days with computers and pads, you can put a small computer on your telescope and control everything from inside the house. And so that works well, and it makes your life easier. So after you've collected all this data, what do? You pack up and go home? No. Now you have to do the dog work, the dark frames, the flat frames, to make sure you get a good background, bias frames. Then you pack up, drive home, and packing up takes a while because you got sensitive equipment. I hope I'm not scaring people about astrophotography, but it's a real challenge, and I do enjoy it a lot. Now, let's talk about one thing that's critical in astrophotography, and that's stacking. You get all these, you might have 50 photos, 4 minutes each, and each photo is noisy and has low signal. By stacking them in the program, you get one photo that's much cleaner and much less noisy. And there's a formula for that. You can reduce, look at the bottom, reducing noise with multiple exposures. It's the square root of the number of light exposures you used. I wanted to make sure I got that. So if you take 4 exposures and you stack them, your noise goes down by a factor of 2. That's really good. If you take 25 photos as an example, you stack them, your noise goes down by a factor of 5. That's why you have to stack if you want to get good pictures. I'll show you some pictures. That's what you came here for anyway, right? Uh, these are different cameras, different locations, but I put them together. This is the Milky Way galaxy in Maine with my C-size SLR camera. Upper right is my M33 Triangulum galaxy. I used a very small sensor because it's a small object. And Andromeda on the bottom right, I use my biggest sensor, a full frame 6D camera, because it's such a big object that you have to consider that. You know what's interesting about these three? These are our neighbors. We're all gravitationally bound. These three galaxies interact, and they're getting a little closer together, but we're safe. Now, I want to show you a nebula I took. This is the Cocoon Nebula, and I want to talk a little bit about field of view, because you got telescopes, you got cameras, you got sensor sizes. When you compose pictures, it's important to think about field of view. This is a nice photo. You can see the nebula is in the center and a lot of stars. But here's another one with a different, same object, a different telescope, and a different sensor to give it a different field of view. And I like this one better. Isn't that the number of stars amazing? And yes, the nebula is the gas cloud is a little smaller. But look how nice the dark lane, that's dark, a dark nebula coming up, it comes out. So keep that in mind, the field of view. So examples of deep space. Galaxies, star clusters, nebula, and the Milky Way itself. And by the way, all the nebula I've ever shot are in the Milky Way, because to go beyond it, you'd have to be someone like Mike who has the skills to do it. Here's a photo I took with my DSLR camera and my telescope a couple of years ago. It's the Leo triplet. The constellation Leo has an area where you have three nice galaxies that are at different angles. And isn't that interesting? And they have strange names, like the one on the right is called the Hamburger Galaxy, because it kind of looks that way. And look at the detail you can get even inside the core of the galaxies. So I like taking galaxies. Of course, you're limited by focal length. You need a lot of focal length to take galaxies. And we are in galaxy season, by the way, as people call it. Star clusters. The most famous star cluster is the Pleiades star cluster. This was an early photo I took with my DSLR. And you can see what's nice about it. You see the stars, but you see the nebulosity, the bluish gases around it. They used to think the stars were formed from those gases. Now the prevailing theory is that the stars are passing through a nebula, and that's why you see the nebulosity like that. And of course, the most dramatic nebula in the heavens, the Orion Nebula. It has everything. It has dark areas. It has a very bright core. This takes a long time to work up because I had to use a 10-second exposure for the core, and I think I used a 2-minute exposure for the rest of it. And I did it over 3 nights, some with filters, and combined everything to get that nebulosity to make it look the way it looks. Like I said before, a lot of times processing is as much work as taking the photo itself. And by the way, you can also see the Running Man Nebula above it, which is that red nebula. How do you find a nebula? My sister asked me about the Orion Nebula because it's one of the few that you could see with the naked eye. And I put this photo from the internet on because if you look at Orion's belt, this is Orion, there's Betelgeuse in the upper left, and you see coming down off Orion's belt, it looks like 3 stars. And the middle star looks a little fuzzy, and if we take a larger picture of it, you can say, that's the sword of Orion. It isn't a star, It's a nebula. That's the Orion Nebula. And believe it or not, that field of view is the same one you saw before, except this was a very short exposure in light polluted skies. If you take more exposure time and stack it, more information comes out. So you see, they're so subtle, these nebula, you have to be careful with them to get the information. And finally, if you go to a dark site and really try over several nights to get a lot of exposures, you can process it into a nice, beautiful looking nebula. That's why people love shooting this. It's easier to find even with a simple star tracker. I promised you I would show you some of my mistakes, or what I now consider mistakes in processing. Okay, there it is. This is one of my favorite galaxies, the Whirlpool Galaxy. One galaxy engulfing another one. Again, it's about 20 million light years away. And you can see I was very proud of this when I took it in 2002 because it has a lot of detail. But again, I look at it now and I say, it's not neutral in color. The colors are off, they're too reddish. The stars are definitely bloated. If you over-process something, you end up getting pictures that look a little bit like this. I didn't know I was over-processing it. I love the photo. My family and friends still like it. But of course, lately, with better software and more skills that I've tried to acquire, I redid that photo with the same data. There it is. I didn't change the data. I didn't take an extra photo. And this is a much better photo. You can see the graininess is less. It's cleaner. It's got a very neutral background. The stars have some color and they're smaller. You can see that you still have the details in the core. And of course, I could do better if I have, it's because I have a bigger telescope now. So it's only a matter of time. If I come back next year, there'll be a third version of this. The other photo I always wanted to get, and I got a couple of years ago, is Markarian's chain. In the Virgo cluster, you can point your telescope or lens, and you can, with enough time, exposure, you can pick up a whole chain of galaxies. And each one is millions of light years. And it's called the Markarian's chain in the Virgo cluster. And when I took this, you could only see the brighter ones here. But when I had the exposure and I stacked it and I processed it to get this, when I looked carefully at it, I counted over 32 galaxies. A lot of them are very small. But anything that isn't round is a galaxy. The photo on the left is taken the North American Nebula, which you saw before, with a full moon. So it's not a good idea. When I was learning, I thought, well, I'm behind this tree. The moon's over there. Doesn't work. I'm going to briefly talk on a slightly more advanced topic, and that is narrowband. And narrowband is, the more you know about astronomy, you realize that nebula are mostly hydrogen gas, an ion of hydrogen, hydrogen alpha, and oxygen, and sometimes a few other things. But so you can get broadband photos, which means all the visible light, like this one. These are two examples of broadband shots of North America. Let me show you what happens when you put a filter in that blocks all the light except hydrogen alpha and oxygen. So there it is. And this is a better photo. So for certain nebula, emission nebula, planetary nebula, reflectance nebula, it's worthwhile to go to a narrow band setup. And more advanced people than me use monochrome cameras with dedicated narrowband filters, and it's even more sensitive, even better. Here's another broadband image. This is one of my favorite photos I've ever taken. It shows the Horsehead Nebula, the dark nebula on the right. And the only reason you see it is because an emission nebula is behind it, so you could see it. And the flame nebula is on the left. And what's nice about this being broadband, you have color in the stars. You have the middle blue star is one of the first stars in Orion's belt. That's why it's so bright. And you can see other nebula, the blue nebula, the reflectance nebula by the horse's head. So I really do like this. I also want to point out that there's a dark nebula on the bottom. And the reason you know that, the only reason you know that is, look at the number of stars at the top half and at the bottom half. Well, the stars are pretty evenly dispersed, but the dark nebula prevents the bottom stars from showing up. So you get a lot of information. I'm now going to show you a photo I took just to test my new filter, and I said I'm going to take a 25-minute exposure only, two 10 minutes and a 5-minute exposure of the horse head. And I did, and that's what I got. And I go, wow. I said, I really like that. It's got even more detail. And if you're an astronomer, you would look at that and say, wow, look at all the hydrogen alpha it's got. All the red is hydrogen alpha, and the blue, which you don't see very much of because I only shot it for 25 minutes. But there's a tiny bit of blue. But what you're looking at is the hydrogen alpha in the Horsehead Nebula and the Flame Nebula. It's a nice shot, and it gives you scientific information, if I could say that. I'm going to show you a perfect nebula to shoot with the narrowband filter, because the center, this is called the helix. I shot this here looking south, and it's low on the horizon. So it's a tricky shot. But the Helix Nebula, by the way, my eye doctors love this one. I showed it to them. Doesn't it look like an eye? Even the brow. But anyway, because of the narrow band, you can see the red is the hydrogen and the oxygen is in the center. And it actually looks, and sometimes it's been called the eye of God. And it is a nebula that's perfect for that. Just one last one, because I'm very proud of this one. 5 hours of exposure. It's called the Pac-Man Nebula, and I like it because I got nice color. And remember the Hubble telescope, the pillars of creation? Well, whenever you see the red areas on the bottom here, you see these pillars coming up, because that's where stars are born. And the bluish is, again, more oxygen. I have to briefly touch on electronically assisted astrophotography, because that's being, instead of doing everything I do, you get a big telescope, you get a computer program, you take short exposures, the program stacks them in real time and shows you what you get. The pictures are more for, that's what they look like off the internet. I didn't take that, I don't do EAA. And you can see there's the whirlpool again, but these exposures are only minutes long. And for here, when we have public night, a lot of times, if it's clear, that's what we do. We shoot, because you can watch the picture get better and better as it's being stacked. Now, you're here at a great time. I couldn't do this last year. This year, right now, there's two astronomical events that were really important. One was the Green Comet, which came by in January. I got a photo of it. And the second thing is happening right now while you sit here. There's a giant supernova explosion that started last month in M101, the Pinwheel Galaxy. And we have pictures for you. And by the way, I'm going to start with the Green Comet. This is the trail, and here's my photo of it. I had to use a wide-angle lens, or it's a telescope, 400 millimeter, and I shot it for about an hour at 90 seconds. Very difficult workup. But you can see the tail of the comet that's facing away from the sun. You see the nebulosity. You see the green glow. That's why it's called the Green Comet. So it was a lot of processing to get that. I have to give credit to Mark Zjarsky here, a member here, who used EAA to get this picture, and you can see that at about 11 o'clock, that's the supernova. It's actually brighter than the core of the galaxy. I'll show you a photo I took last month before the supernova. Here it is. I happen to take the same galaxy, different lens and all that, but you don't see that bright star at 11 o'clock. And if I of course took my new big telescope and I had to take some photos of it, so I took 2 hours of photos. That's what I got. And you can see there's a bright star on the arm at about 11 o'clock that's brighter than the core of the galaxy. And if I blow it up for you, there it is. You can kind of see how bright that big bright object is. That wasn't there a month ago. It's going to be here with us for a few months. No one knows exactly. And then it's going to disappear again. Because a supernova is a giant red star that collapses once it runs out of enough hydrogen to burn gravitationally and explodes in the brightest explosion that we know of. So you say, wow, what if that happened close to us? And I have news, it has in the past. There was a supernova in our Milky Way galaxy between 10 and 20,000 years ago. How do we know? We know because there's a supernova remnant left behind, the shell, the gas, and I have a picture of it. And what happens is, it's called the Veil Nebula. So the sun that exploded, or the star that exploded in the Milky Way, was about 20 times bigger than our sun, and it was so bright when the supernova occurred that if you were alive 20,000 years ago, you would have seen it in the daytime as a bright star. That's how bright it was. And here's my photo of the remnant of that supernova called the Veil Nebula. And this is a narrow band image. You can kind of see the house. This is 50, I want to say 50 light years away. But I could be wrong. I have to check exactly how big this is, but it's a very large nebula. I had to use a wide-angle type telescope to get the right focal length. And you can see the details, the greenish blue, the red, and that's what's left. And that's what's going to be left in the other galaxy once that's gone. So the summary, it's all about the photons, what we started with. Photons make the critical signal to noise, because remember, you're shooting very dim objects. With the digital sensors, we can stack them. Stacking is critical. And the more photons you collect, in other words, the longer exposures you use, there are people here at our club, more advanced than me, that have 20 hours on one object. The most I've ever done is 7 hours. Here's a nebula that is processed in broadband and not very well processed years ago. And here's my current photo. And I used the Hubble palette. There's a sequence of colors you can apply, like the Hubble telescope, and you can get nice blues and reddish hydrogen. And that's the same nebula. This is called the Rosette Nebula. My longest is a dark exposure. This is over 3 nights, 7 hours. M78. It's called Casper, the nebula. And so my wife loves it when I set up my new telescope in our living room. She's back there, so but it does take a lot of work, and you can see the guide scope, the cameras, the tripod. And here's my first photo from Parsippany, New Jersey. This is M13, a star cluster, and I was very happy that my collimation was good. A narrow band image from my house in Parsippany. This is a very small nebula, the Owl Nebula, and I'm very happy with the results so far. And I'm not going to go into the natural progression. You've heard me talk about it, from a stable tripod to tracking mounts to beyond the universe. And I love deep space. It's a challenging hobby. You've got a lot to learn, and it's a learning process. And I do like to impress my family and friends. Thank you.
All right. Thank you, Mike. Excuse me. Thank you. Trying not to trip over all the wires. All right. So we will be having a question and answer session. Before that, for the people who did sneak in during the talk, you do not get to escape the safety briefing, as much as people would love me to. Porta potty in the back to my left, your right. We have a gift shop and museum area where you can look, and feel free to look at our meteorite displays and various telescopes we have in there. In each of those sheds with the roll-off roof, each one that has a rolled-off roof houses its own telescope, and when you go and ask the volunteer who are running the scopes, you will be able to either see what they can see through the scope, which looks like clouds. By the way, visual scopes cannot see through clouds. Radio telescopes, yes, but those are not visual. So, to head off that question, no visual scope on Earth-based is able to do that. So, again, when we leave, headlights on because we don't like getting run over, and I'm sure you agree. And also, any flashlights we may be using to wander around, keep them pointed towards the ground because we don't need to accidentally blind people. How question and answer is going to work for the people here, because I am night blind because I've been staring at screens. You'll raise your hand and kind of wave it around and keep it around until I get to you, so you could speak your question into the mic so our online audience can also hear. With that being said, let's start off question and answer with our first question from online. What has been your favorite astronomy object to photograph so far?
It's a tough question, but I would have to say it's my first one, Andromeda. And I've shot it, I think, every year since I've been doing deep space astrophotography.
Can't get over your first love, can you?
No.
All right. A question from our audience here? Bueller? I don't even get crickets this time. It's been windy. They're all hiding. All right. So our next one. On that topic, what is your least favorite object you've attempted?
Least favorite?
Yeah, probably the one that's given you the most grief.
I can't answer that. They're all a challenge, and if you enjoy the challenge, you enjoy making something work. The horse head was an example where I struggled with it. I didn't have the right equipment. I couldn't get it. It was greenish looking when I first started, but I really wanted that one. And it took me a while, but I did get it. And I guess the most frustrating things is when you have a very small, interesting object and you don't have the reach with your telescopes to get a good photo. That's frustrating, and that's why I got a bigger telescope.
The never-ending story of aperture envy. He's nodding because he's also secretly planning on that next bigger scope.
No, I think that's it.
Again, any questions? Oh, it's a tough crowd tonight.
Did you say how long you've been doing this?
Well, I think I did on a tripod. I've been doing I've been doing photography for a long time, but 3.5 years or so for this, and there's a long way to go. I didn't have time to go into more advanced things people do with monochrome cameras, autofocusers. There's just a lot to this hobby. I think it's a lifelong pursuit.
All right, so our next question is do you need a cooling system, or can you just like set up a little desk fan or something blowing on everything
Oh, you mean for the
for the
sensor?
I'm
Uh,
guessing.
yeah, I did talk about cooling sensors, and first of all, y- a fan would not be good because even when the breeze picks up, you could have problems because you've got a rig set up that's tracking very precisely and guiding to get those pinpoint stars. So anything that interferes with that, and a fan might interfere. It also wouldn't cool it enough, and even worse, it would cool it to an inconsistent level. When you use an Astro camera, you set in the controls that you want it set for minus 20 degrees centigrade, and it'll once it reaches that temperature, it keeps your sensor at minus 20 degrees centigrade through your entire photo setup.
All right. I also had made a note in the online chat because I will forget some of my questions because I don't have perfect focus like your photos do. Um, that your photo you have of the Milky Way from Maine is actually featured in our 2023 astronomy calendar, and
Oh, yes, it is.
I've kept myself from looking at your submissions for the 2024 uh, calendar just because I'm like I want to open them all at once and be surprised like it's on Christmas when I get everyone's images.
Yeah, we have a real nice group of astrophotographers that have helped me tremendously, and the internet has been really important too. I, I do want to say that the technology does keep improving. So even as we speak, there's new mounts coming out that don't require counterweights for certain limits, which makes setup much easier. And for me, it's something for the future.
All right, so our next question, and I'm assuming they're setting this up like it would be one of those weird internet challenges people do,
Yeah.
where would it be possible to get a start in the hobby and get decent images if you were to challenge yourself to only use things you find or buy off of like Facebook Marketplace or Craigslist for no more than $100? Do you think you could do that?
It'd be a, a, a total of $100.
I'm guessing. I think we would have to think through that
I, I could
internet
I
challenge
could
a bit more.
I could recommend a good filter. That's about it. No, it is an expensive hobby, and the the least expensive setup would be a simple mechanical barn door tracker you could build yourself, and then an SLR camera with a timer, and you'd get something, but it wouldn't be very good. So it's an expensive hobby.
Hey, it would be an interesting challenge to see like someone more experienced in the hobby decide, you know what? Let's get back to basics and see what I could do with that. Right. Again, at any time, if you guys out here have questions, just kind of wave,
Okay.
because again, blind, so just holding your hand up, I won't realize. Right. So the next question is, why do all your pictures of the same object have different coloration? So like you had a couple up there where
Yes.
you showed A/B comparisons.
Right. The most dramatic differences I showed where objects have totally different colors are the ones where you're using all the wavelengths of light, red, green, blue, and the ones that you limit which light goes into your camera, and that's the narrow band. Those are dramatically different because you're limiting how much light and what wavelengths of light you're allowing to go in. And of course, different wavelengths of light are going to have different colors. And the way you process it also, the processing softwares have gone very sophisticated, and you can you can assign certain wavelengths of light to certain channels and make them come out different. Some of this is for science's sake. In other words, you want to see some hydrogen alpha, some oxygen. But when your eyes look at an object, they wouldn't be seeing that. They would be seeing the broadband, the full spectral wavelengths.
All right. So, because I do know we have a couple more online questions, and if you guys have any questions, feel free to jump up and or just stay sitting. You don't have to jump up. I also get it. So last call for our online questions. Get those in, just because I know it takes a couple minutes for you guys online to get the message rather than our in-person audience. So the next question is, are there different patterns of batten-off masks, or is a batten-off mask a batten-off mask?
There are no easy questions, but a batten-off mask is a batten-off mask. Let me just say that. The interference pattern I showed you is always the same. You have an X, two lines crossing, and a third line that moves up and down. When they're all concentric, or when they're all meet at the point, you've got perfect focus. There's other masks, tri-batten-off masks, that have to do with collimation as well as focus, but a batten-off mask is the same.
So the pattern that you showed of the physical mask is always pretty much going to be the same.
Yes.
Neat. Because that's actually one of the questions I had.
Oh, yes.
Because I know James makes them. I'm like, is he out there doing funky, weird things by himself, or?
Yes, people 3D print them. There are differences in the quality. Some make them out of clear plastic. Others are darker to let in less light. But they all work pretty much the same. But remember, to do a perfect focus, you do need a bright star that you can center in your optics, and then you do your fine focus, lock it in, and hope the temperature doesn't change too much and affect your focus.
All right. So coming down to the last couple questions. For the this is regarding the people who have multiple rigs going at once.
Yes.
Are they combining all the images from the multiple rigs, and would that pose challenges with, objects aligning if they are?
Okay, that's a really good question. And the answer is some do and some don't. In other words, if you have the same focal length telescope and a similar camera, the sensor size, then yes, you can combine them. And it doesn't matter whether you take one, when you stack these images from two different rigs and everything is the same, they get corrected. In other words, a little bit of rotational differences, a little bit of centering differences. You lose a little bit of your frame when you combine it, but you will get a good photo. Most people that have multiple rigs are shooting different targets. You might be shooting Orion and the Rosette Nebula and Casper and maybe a galaxy. And so, of course, there's a lot of work setting them up, unless you have your own observatory at home, which several of the people that photograph here do. And they have a pier set up, so they just go out and start it and go inside.
At least now, I always find it funny because I always say, oh, I don't even have crickets, and then the crickets started. Any questions from you guys? Come on, you have to have at least one. No questions you want to add, Mark? You to try and stump Mike? Ooh, this is going to be good.
How would you recommend to use the batten-off mask on a remote system?
I'm sorry?
How would you recommend to do a batten-off mask on a fully remote system?
It's an easy answer. You don't need a batten-off mask in a fully remote system because you have an autofocuser, and it uses a even more sophisticated method of getting the actual focus. And I think you know that, Mark. Oh, No, if you use an autofocuser, then I should have made that clear. Uh, Everything's automated. If you've set it up well, you'll get great focus. And the nice thing about an autofocuser, beyond the Bahtinov mask, is if the temperature changes or you're changing filters, you have to sometimes refocus. Well, you can program the autofocuser that every hour or every 2 hours it refocuses automatically.
Yeah, Mark's going, now there's things I need to code for the people who can't actually hear him online because that's a project he really enjoys. And my more facetious answer to that is, how much are you willing to pay someone to go Bahtinov on, Bahtinov off, Bahtinov? I'm I'm sure you could find someone to go, you just call, put the mask on.
Okay.
I don't know. I thought it was funny. I at least heard a couple giggles. Right. So, last question of the night, unless someone else has a lovely question from out here. And this one is more of a funny one. Do you mean when Astrophotography Day is weights day in the astronomy gym?
What's the question?
Yeah, you were going off on how you have counterweights and this
Yes.
is heavy and that's heavy. So it's lifting day in the
Oh.
astronomy gym.
Definitely it is. I have to say,
No skipping leg day.
when I was selecting my mount, that was a serious consideration. Some of these mounts are heavy. You're talking 30 pounds, and to lug that around, I'm not as young as I used to be, so I got a lighter mount, and it's worked out very well. The newest mounts, harmonic drive mounts, use different gears and a different technique, and they don't need counterweights, so you can save more weight that way, and it's great for travel.
Yeah, and
Thank you.
that point actually brings up the whole thing. The best telescope setup is the one you're actually going to want to take out and use, and weight is in fact a consideration of why many of us don't go for those larger things. All right. So, since it looks like we've exhausted all the questions, I want to once again thank you, Mike, for a great presentation. I want to thank you all for joining us not only here but online. And like I said, feel free to ask questions of any of the volunteers, or even if you think of a question later, feel free to email that to us, or find the archived video on YouTube and ask it there, and I'll get an answer to it. And with that, have a good night, everyone.